So let's look at, we're gonna drill down on audio over IP, which is, as I say, a subset of networked audio in general. If you talk to some companies, they say, no, don't use IP, just use our totally proprietary, I mean, basically down to the wire proprietary system, because it's purpose-built for broadcasting special needs. Okay, and that's one way to go. But basically there, you're just, you're saving some on wire count, but you're rebuilding the system in general. It's kind of like the old Pentagon procurement. And this is how you come up with $700 toilet seats and $100 hammers and things, because they're built to spec, and you only build a few of them. Well, if you can leverage, as we have leveraged the PC and the Mac platform for audio recording, storage on servers, all these things that now are so cost effective today. I mean, just almost practically free in some respects in terms of just being software based, because we leverage the power of the PC platform. Now we're just also leveraging the power of the PC based or computer world's networking. Now notice that we're talking about IP here, Internet Protocol. We're not talking about the Internet. So this is not audio over the Internet. In fact, audio over IP is very much specifically limited to the LAN environment, not the WAN, not the Internet. Now you can have Internet-based connections because it's still just IP, but when you're talking about an AOIP system, it's literally limited to a LAN in a facility, and as a result of that, you get some really great advantages of things, and there are issues that we know about with the Internet and its robustness problems and reliability problems that just completely go away with just today's off-the-shelf networking equipment, because you're just, dealing with a LAN. So we're taking this most standards-based approach in audio over IP, and that really does maximize all the leveraging you can on the cost effectiveness of off-the-shelf computer networking stuff. As we said, for LAN only, and it is mostly the AOIP-based systems, of which there are several, and they do differ a little bit, but again, they all share the core of being standards-based as far up to the stack as they possibly can. And really, the only thing that you need to get rid of with IP, or need to add to a basic IP system, is the fact that broadcasters need very low latency through the system. You need to be pretty much real time as much as you can. And IP-based systems, as probably most of you know, can have some latency. Certainly they have it over the Internet, but even in a LAN, they can have some. And so you want to try to get that down to the minimum possible amount. And also, you don't know what the path length is actually going to be. It may be fairly circuitous through the system. You still want to keep that latency as low as possible. So each link has to be super low so that it doesn't add up. Now this is the argument that the folks that say don't use IP because they say too much latency, yeah, you have to get around it somehow, and that's, if you're going to do that, you might as well do it all without going through IP. As we said, there's some disadvantages to that too. The other problem is that there's a lot of the IP header. Do you really need all the power of an IP header when, which is designed to basically, and the IP and the Ethernet header basically, we'll look at the packet structure in a minute, that is really designed to handle the entirety of an address space for the universe, basically. Do you really need all that when all you're doing is going to a finite number of places within a network? Well, if you can do it without balancing the latency involved, why not? Because it means that you have this infinite scalability in within your system. So what we're dealing with in this case, and I think the smartest way to go, is a pure standards-based, or as much as standards-based as possible. And notice that we're talking about both Ethernet as the physical layer and then IP above that. And those are two different standards that are two different standard spaces, one of which is the IEEE's domain, and the other is the IETF, Internet Engineering Task Force's domain. And we'll map that out in a second. So finally, just to put a exclamation point on these advantages, we said cost effective, obviously. It's also really quick to go up. I mean, literally, you put the console into the cabinet and you plug in an RJ45 and you're done, as opposed to punch blocks and XLRs and snakes and so forth. So, this can work in sound reinforcement the same way, just replacing a snake. We'll show some applications at the end that include that, not just for broadcast or even for recording studios. And then the real sort of future-proofing benefit, this is, nothing scares engineers more than building something that's out of date the day you finally open the doors, right? And it can happen. Things change faster than ever, and they're not slowing down any. So having any kind of insurance policy against that happening is great. And certainly an IP-based system, that's one of the very natures of the design of IP, was because they envisioned almost unknowable needs in terms of scalability in the future. And this is just with IPv4, for those of you into this stuff. IPv6, I think they said you could have an IP address for every grain of sand on the planet and still have room to grow. So I don't think we need that quite that much. But the console that has the soda machine between input 117 and 118, we don't really have those too much anymore. But you still do have large systems, and the needs for accommodating these inputs and outputs don't rely on just add more cross points in hardware to a router anymore. So there's really some definite benefits there. And the final point is, look, all the stuff that we're working on, all our terminal devices, our sources, our recorders, everything, once you get a little bit past the microphone and a little bit before the speakers, and even in some cases now the microphones and the speakers, basically talk this language anyhow. So why not have the entire end-to-end path, as much as you can, also talk that same native language? What this really means is no more sound cards, or you don't need a sound card for every channel of audio. Literally, it's one IP connection, and whether it's a 2-track or a 64-track input stack, it doesn't matter. It's still one cable. So, and you don't have to keep throwing cards on the bus there to handle it.